Hello everybody, myself Anil Kumar Bisht. In the occasion of second International Motivational Conference on Current Research Trends 2021, I'm here to present a research paper titled Analysis of Support Vector Machine Model in Forecasting the 1 year ahead water quality of the river Ganga. As we know, water is the basic need for any nation to live. It is the necessity. It is fundamental part of what is required for both to live as natural life everywhere on the world. The main sources of water are rivers. In India, our national river is Ganga River. It's the Ganga River. But in recent years, it has been noticed that even the quality of water quality of Ganga River is deteriorating day by day. So it's in need of current hour to find such technical solutions, to solve this water quality problem, particularly for this river. Determining the water quality of rivers is much complex because of the complex and non-linear relationship between the factors responsible for deciding water quality. Its accurate prediction indicates the advancement of the system and the actions as a whole by water management authorities in order to adopt preventive measures. During the last few decades, there has been tremendous progress in the field of AI, particularly solving the problems of pattern recognition. Support vector machine has been applied successfully in forecasting. Based on historical data, support vector machines can be able to perform non-linear mapping between a given dataset and its elements, identifying the trends and patterns in the given data so that the desired output will be produced. Artificial neural networks techniques for water quality forecasting has been analyzed by the authors in previous cases. Support vector machine is analyzed in this paper on the same data set for the Ganga River. Purpose of this paper is to analyze and develop various forecasting models in 1 year advance for the Ganga River water quality based on support vector machine approach using a time series experimental dataset for a period of 15 years from 2001 to 2015. Many researchers and scientists applied the concept of artificial neural in support vector machine. Some of them are like Istanbul Stock Exchange Price Index prediction based on ANN and SVM, weather predicted using NN and SVM, inclusion detection using NN technique with SVM method, the Marlet-Wines method on SVM and ANN and SVM that predict the metabolized energy required in the compound need for fakes, feed for compound feed for fakes. In addition to these applications of ANN and SVM models, these concepts have also been applied in the area of water quality, modeling the rivers, like the application of PNNS1 methods in predicting dissolved oxygen, one of the parameters of determining the water quality is dissolved oxygen. Similarly, authors in this cited paper number 9, the reference applied SVM for biomonitoring and water quality assessment based on multi-class support methods. The study of literature leads to the conclusion that despite the importance of Indian-based models in various fields, including water quality prediction, no such technique is still applicable to modeling Indian rivers, Indian situations, Indian environmental conditions. In relation to this, not a single research has been done to the best of authors to include such technical solutions for the water quality of India's national river Ganga, whose water quality is deteriorating frequently. Keeping all these facts in mind, this chapter or paper deals with the development of water quality forecasting model to the Ganga. For the study purpose, we have taken the Ganga River basin in India. While as far as data set concerned, past 15 years continuous data sets on the state of Uttarakhand in India, comprising 5 stations, Devprayag, Rishikesh, Haridwar, Jalapur and Roorkee, analyzed by the Limnology and Ecological Modeling Laboratory in Uttarakhand People Common University, Haridwar has been utilized. They're comprised of various parameters like temperature, pH, and etc. This is the study region and the data set. along the 5 stations analyzed that has been used here. The process of model doubling using SVM-Weka tool. Based on technique of support vector machine, all the experiments are performed in Weka tool for developing and analyzing the performance of various water forecasting models for the Ganga River. Support vector machine basically provides a learning method that aimed at pattern recognition. Classify built on support vector machine divides the mentioned data sample into 2 distinct categories by drawing a straight line known as hyperplane to implement the classification task. Suppose input data set known as input vector A1 B1 from A to B2 from A3 B3 and so on to AN BN, right? AI belongs to I star T while I is from 1 to 2 to 3 to N. The primary function of support vector machine involves designing a hyperplane assuming the feature vector A and label B so that it makes the best class in such a way that -1 and +1 of input data with 2 output classes represents the classification. It means a clear-cut classification among the 2 sets, negative and positive. The main focus as well is to draw the hyperplane as a separate boundary with the goal that it maximizes the separation between the data points surrounding the 2 ranges with respect to the different plane. These data points that belong to 2 different categories are support vectors. This distance is defined by term margin. As highlighted here, you can see here, these are the data points across horizontal vertical lines x1, x2. These are belonging to category 1, these are belonging to category 2. This is the margin defined by support vectors which are lying along its both sides. This is the best type of plane dividing these 2 planes. Let's find the distance as here. Next has the separation between the data points. It is margin. Now, the majority of this present reality issues are not linear in nature. That they cannot be categorized into directly divisible categories as above. So, in order to handle such non-linear support vector machine, which are based on mathematical function called kernel function, are much beneficial. A kernel is defined as a mathematical function whose main task is to implement the concept of non-linear support vector machine, supporting the issues in the real world involving nonlinear trees to solve nonlinear problems. A number of kernel functions are there: polynomial, radial basis, sigmoid, etc. Among these, most ordinarily utilized by several researchers scientists is the RBF. The RBF is defined as this equation where gamma represents the constant in RBF whose value need to be larger than 0 and mode of AI minus AI represents the distance from x center to the xi interval as equating distance. After selecting the RBF, radial basis function and a comma separated value file of that as a discrete. Secondly, this file is converted into Weka compatible file format called ARFF attribute file format. As supervised machine learning approach, SVM is used to create a predictive model by setting its parameters in Weka. Now coming to results, in order to analyze the performance, the following 4 matrices are being used: mean absolute error, mean absolute percentage error, mean squared error, and mean squared error. Considering the first station, Devprayag, the proposed support vector machine model was developed, and the highlighted here, the values with asterisk determines the next 12 months, 1 year advance values for the water quality as here, with 4 performance matrices as shown here. After analyzing the results, 1 step ahead, 2 step ahead, to 12 step ahead, 12 months ahead, what we have got? We have got this future forecast result and the performance of developed model as in this table number 3 is computed using various measures that should provide results that the developed model obtained just a very poor accuracy of 19.07%. Best among others as the minimum MSE is 0.8093. Minimum MSE is 0.8093. That means only 19.07%. So support vector machine for this station data doesn't provide satisfactory forecast. Considering next station is the case, Having the same four parameters, we have got this future forecast that provides only 11.43% accuracy, not as of the expectations. Considering for third station Haridwar, the same model after applying same parameters, forecast is only 11.43%. Once again, this technique lead to produce an efficient forecasting model for this undertaken problem. For the fourth station Jwalapur, again the machine only achieved 13.47% accuracy. This one is the forecast. These are the four different parameters having their respective values. For the fifth station Roorkee, again the machine accomplished a superlative accuracy of only 39.39% in forecasting 1 month advance as highlighted in this table number 11, which again not up to the mark, not a satisfactory forecasting performance. While in an effort to develop a water quality forecasting model, the conclusion is that using a technique of support vector machine, the results led to the very poor performance, not perform efficiently for the current data set. However, if we compare these results to our previously done research published in this paper in 2019, published in this paper cited here at number 1 in the reference, results compared provide us the result that we found ANN artificial neural network performs well in SVM. So they are totally purely outperforming SVM techniques. ANN performing particularly well in this case for this particular problem using particular circumstances, outperforming support vector machine in forecast. It is noted that with this paper, the SVM achieved the best mode accuracy of only 30.29% while using ANN we found 100% accuracy as we have done in this paper, but it is one in the difference. Therefore, in the future, more attention needs to be required to be paid for improving the current water quality forecasting model for a river based on support vector machine model technique by including changes in another configuration parameters for the model, such as changes in kernel function, etc. So that's all in this presentation of my paper. These are the references. This is number 1, where we have highlighted the performance of ANN, and where we have compared it with SVM, and ANN outperforms SVM. SVM failed to achieve their expected results. Thank you all, and we're closing my presentation. Thank you.